Hello students, today we are going to learn about the t-test. Already we have learned about the z-test, so let us go through this PPT and find out how t-test is different and when to implement t-test in place of the z-test. Let's start with the introduction. Here we have given as the first main thumb rule for applying the t-test is that the sample size. Whenever we are testing a hypothesis, we have to take out a sample. So the first thumb rule is whenever the sample size is either equal to or less than 30, then we can apply the t-test. And when we can apply the t-test, this is regarding the sample size. Other than that, we can apply the t-test to find out the hypothesis testing for mean and the hypothesis testing for the two means. Correct? So this is what we are going to do now. If we talk about the sampling distribution of a sample mean, then normally when we talk about the sample to be taken from a population, then we take the z-test and given by the x bar minus mu divided by sigma by under root n. But if we take s in place of sigma, then we are applying the z-test, but actually it is not normal. So what we have to go for, in that case also we can't apply the z-test, we have to go for the t-test. As the name implements, here we have written students t-distribution. So t-test actually come into the existence when a teacher given the formula to be to the students to learn about it, and where they have implemented this test and obtained some useful results. So on base of the students' effort, the professor have given the test name as t-test. Correct? If we talk about this, then the important characteristic of this student distribution of the t-test is the degree of freedom. Now what we mean by the degree of freedom is whenever we are talking about 5 items suppose, then we know that 4 can be easily taken by any number, and in order to get some particular value, 5th must be up to a particular mark. So that is known as the degree of freedom, that if we take it the same example of 5, then 4 can take any value, but in order to get a particular result, the 5th must be taken accordingly. So here when n items are there, n minus 1 are free to take any value, and to get the desired result, we must have to work for the last. So how many degree of freedom is there? There is n minus 1 degree of freedom. Correct? So this is what it means. And the formula we see, t is given by x bar minus mu divided by sigma by under root n. In place of sigma we have taken s. Why? Because here we have the standard deviation given for the, or we have to calculate it for the data. It will not be given for the population. And how to calculate the standard deviation? I think all of us are aware of the formula, that the standard deviation of the sample is given by s under root of summation x minus x bar square. Here it is divided by, divided by n minus 1. Like this. It is not visible in the video. You can go through the PPT that already we have. So we have the same formula written properly. Correct? So this is what we have to do to calculate the standard deviation. Now if we talk about what are the properties of the t-distribution, how it is different from the z, then the first thing we have to note down that it is not a bell-shaped curve. It is, the shape is known as a mound shape. It is not a bell-shaped. And the property of the symmetricity is same here. The t-distribution curve is also symmetric with respect to 0. One more thing that you can note down, it is more variable than z, that is it has heavier tail. And the shape depends upon the sample size, or we can say it depends upon the degree of freedom. And one of the important characteristic of the t-distribution or the t-test is it leads to, or it tends to the z or the normal distribution as the sample size is going to be increased. It means whenever the n value is going to be increased, t-test is approaching the normal distribution. Here I have shown you two curves. Here it is visualized easily, that here one of the curve shown by the red is a normal distribution curve, which is a bell-shaped curve, which is this one. And if we talk about the inner one, here you can see we have taken the mark of black. So the inner one is the t-distribution curve. Here you can see in the tails are heavier as compared to the normal distribution. It is approaching and continuously going to the infinity. So these are the two main difference between the t-test curve, the mound shape curve and the bell shape curve. Here the same thing is written here, that the interior distribution, the first thing is it is symmetric distribution with respect to mean 0, and the distribution extends to infinity or the either side. Now if we talk about the numericals, what we are going to do and how we are going to do. So the first step is always same, that we have to frame the null hypothesis and the alternative hypothesis. And how we are going to do, we are going to take a statistic t given by x bar minus mu divided by s by under root n. And how we have to reject it, we have to reject it based upon the degree of freedom. Here df represent degree of freedom, df is equal to n minus 1, and this is very important with respect to the you can say the MCQs, that the degree of freedom of n items will be how much. So it is n minus 1. The degree of freedom is n minus 1. This is, you have to note it down. It can be asked from that suppose we have taken a sample of 10 and we are asking from you what is the degree of freedom. So obviously it is 9, means 9 items are free to move and the 10th one is bounded. Let us go for an example. Here we are saying, let's read it out. The sprinkler system is designed so that the average time of the sprinkler to activate after being turned on is no more than 15 seconds. And average time is given, it means we are talking about the mean, correct? And we have tested a 6 system giving these times. It means what these are the sample values, what we are getting as a time. What we are looking for, is the system working as specified or not. So test using alpha. Now what alpha is a level of significance. Now again we have to go for creating H0 and HA. So here what is H0? H0 is saying mu is equal to 15, means whatever we are looking for, that working as specified, and mu greater than 15, because here we have written no more than. So from here we will come to know we are talking about no more than, we take always the opposite one. So HA is mu greater than 15, correct? If we go through the next one, what we have given, we have the data given to us. So what we have to do is the first step, we have to calculate the sample mean and the standard deviation. So using the formula x bar is equal to summation of x bar, and we are getting value as 20 and the standard deviation is coming as 7.9498, and be sure to calculate it so that you will get the calculation part also. So here if you have calculated by substituting the value of x bar, mu and s by under root n, here the value is coming as x bar minus by s by under root n, the value is coming as 1.54. and what we have, the degree of freedom, here in this case is n minus 1. We are talking about 6 data values, so degree of freedom is 5. So what we need of why we need this degree of freedom is to find the standard value of t. Here in z test we have learned that the standard value would be remembered by the experimentalist, we can say, but here it will be given to you, or you have to look at the end of the book in the appendix. So here we are saying that the rejection region is, we have to reject H0 if t is greater than 2.015. so what it is the value of t at 5% level of significance and 5 degree of freedom. So this is how we have either the value will be given or we have to obtain. So this is the standard value. Now what the value is coming, we are getting the value is 1.54. so we can make a decision. Here you can see the test statistic is value is coming as 1.54, and we have to reject if t is greater than 2.05015. So what you have to say, that H0 is rejected. I think there is a mistake. Here we have, for example, t is 1.54 does not fall in the rejection region and H0 is not rejected. Here we are saying that we have to reject if t is greater than, okay, correct. No, I got confused. Here we are saying that we have to reject if t is greater than 2.015. So the value is not greater than, it means H0 is not rejected, correct. Let's talk about the next example, that in a sample of 8 patients, mean DMFT value is 10.3 with standard deviation 7.3. Is this sufficient evidence to show and conclude that the mean DMFT value is greater than 9? So here we are talking about something which is greater than 9. So here we have mu is equal to 5, which is a H naught. Mu greater than 9 is our HA, the opposite one. And the statistic is given in this. The data is not given to you. It means we have been provided by the some more data values. If we talk about what the things given, sample of 8 patient means here we have the value of n. Mean DMFT value, it means we are talking about x bar. And if we're talking about standard deviation is so these are the value given to us, and we are using the 10% level of significance. And if we talk about what is the degree of freedom, we have n as 8, n is 8, so the degree of freedom is 7, correct? So if we have to go for the t standard value, we have to look for the t at 10% level of significance. It is one tail test, and we have to take the degree of freedom. So if we talk about, here we are getting t alpha 7. This is the way to write down t. Here we have the level of significance followed by the degree of freedom n minus 1. So it is given as 1.33. and if we talk about the value we are getting, so the value is coming as 0.503 and the standard value is 1.333. So as per the decision we have done in the normal distribution, or we can say the Z test, here also the null hypothesis is not rejected, or we can say accepted, which means DMFT index is not greater than 9. Let's take an next example. Here again the data is given to you because the sample size is small, and the data is saying the pulse rate of man on the different days in a month is found to be these. We have to discuss whether the mean pulse rate is 65. Now here we are saying is 65, it means either it is 65 or not 65. So the null hypothesis is mu is equal to 65 and the alternative is mu not equal to 65. So this is about the H naught and HA. And if we talk about it is which tail test, two tail test, because it is equal to and not equal to. And here I have not shown you the calculation. You can calculate by yourself. The mean value x bar is 67.5 and s is coming as 2.79. And if you have calculated t from the formula, x bar minus mu divided by s by under root n, the value is coming as 2.82. And at alpha 9 means at 5% level of significance, which is alpha, and the degree of freedom is 9 and minus 1, so it is coming as 2.262. so we have to take a decision that null hypothesis is rejected because the value is more than the standard value. The next topic, which is the t test for the difference of two mean. So it is similar to what we have done in the Z test. So let's see it out and see how it is difference in same. Here again, when we're talking about the difference between two mean, we have the two random samples. Let us take the sample sizes n1 and n2. They are being drawn from population 1 and 2, and the sample means are x1 bar and x2 bar with variances s1 square and s2 square. Now again we have to check between the two population. So we have to take H naught. H naught is saying that mu1 minus mu2 is either 0 or some value. And what is H1? H1 is 1 of 3. 1 of 3 means either greater than, less than, or not equal to. Correct? But normally it is taken as 0. That H naught is mu1 minus mu2 is 0, means mu1 mu2 are same or they are different. And one more assumption is there that you have to remember, that we are going to apply this t-test for the difference of two mean with the assumption that sigma 1 is equal to sigma 2. The population standard deviations are same. When they are not same, then the formula will be changed. But here whatever we are going to do, we are assuming sigma 1 sigma 2 are same. So more assumptions are there, that the two samples must be independent, they must be simple random sample, and the sample size must be less than 30. Under these assumptions, we have to take the t-test given by x1 bar minus x2 bar minus d naught, which is normally taken as 0, divided by s square, which we have taken common, into 1 by n1 plus 1 by n2. And here you have to note it down that we have to calculate s means the standard deviation using this formula. Here if s1 square is to be there, s2 square we need to be there, n1 n2 need to be there, and using this formula we can calculate s square, and then this s square is substituted here in the denominator. And if we talk about in this case what should be the degree of freedom, so the degree of freedom is given by n1 plus n2 minus 2, because in first case when we have learned it is n1 minus 1, and in the second case it must be n2 minus 1. So as a sum of 2 we will get n1 plus n2 minus 2. So this is how you can remember it. Let's start with an example. Here we are talking about two training procedures which are compared by measuring the time that it takes to assemble a device. A different group of trainings are taught this method, and we are looking for is there any difference between the two methods, so they are giving the same output. So here we have been provided with the values. The sample size means we are talking about n1 and we are talking about n2. Mean means we have x1 bar, we have x2 bar. Sample standard deviation means we have s1 and s2. So what we need to do, first we have to write down h0 and ha. H0 is either they are same or different, so mu1 minus mu2 is either 0 or not equal to 0. It means it is a two-tailed test with alpha 10%. We are talking about t statistics, so this is the formula given to you. On applying the formula of s square first, we need to calculate the value, and then we have to substitute it here. Means first value to calculate is s square, n minus 1 into s1 square, n2 minus 1 into s2 square, divided by n1 plus n2 minus 2. And if you remember what this is the degree of freedom, correct, for the t test with two mean. And using this s value, this we have substituted here and calculated the t value. T value is coming as 1.99. and if we talk about the standard, so standard is to be calculated as n1 plus n2 minus 2. So here the value is coming as n1 plus n2 minus 2 is 20. It means we are taking the value of t at 5% level of significance. I can write then 5% as 0.05 and comma, what is n1 plus n2 minus 2, it's 20. And if this is the value required, either you can look at the appendix or the value will be provided to you if you are doing in the examination. So the value is 2.086. Here if we talk about what value we were getting, so the value was 1.99. so obviously it is very less than the standard value. It means null hypothesis is accepted or not rejected. It means two methods are not different, because what assumption we have is we have taken that h0 means the mu1 minus mu2 is 0, correct. So when it is accepted, it means mu1 mu2 are same, so they are not different. Let us take another example. In this example we are talking about the samples of two types of electric bulbs that were observed for their length of life, and following the observation we are looking for is there difference in the mean. Is the difference in their mean is sufficient to guarantee that type A is superior to type A. Means we are comparing the mean life of type A and type B. We have again been provided with the value of n1 and n2. The sample size n1 and n2 is given, x1 bar x2 bar is given, and s1 and s2 are given. So the first step is, if you remember, first we have to calculate s square using the formula. This using the s square we need to calculate the value of t. But prior to that, what is the first step? The first step is how to write on h0 and h1. So we sure to follow all the steps. Here if we see h0 and h1 is defined, s square is being calculated, t is calculated, which is coming as 10.1. and if you can see here and observe which type of test is this. So it is a two-tailed test or one-tailed test. It is greater than sign, so it is a one-tailed test, correct. So it is a one-tailed test, and the t value at one-tailed test at 13 degree of freedom. Why 13 degree of freedom? n1 plus n2 minus 1. Let's go back and find out what were our n1 plus n2, 8 and 7. So if we talk about 8 and 7, so the degree of freedom is 8 plus 7 minus 2, so 8 plus 5 13. So here we have taken 13 degree of freedom at 5% level of significance. The standard value is 1.77. So the value obtained is more than that. It means null hypothesis is rejected. Correct. So today what we have learned about is, we have learned about the t-test, when to be used, how it is different, what is the shape when it is approaching the normal distribution. And then we have learned the formulas. The difference between the t and z formulas are, the first thing is, there we have taken sigmas, and if not, then we have switched to s. But here sigma will not be given, we have to use s, and in case the data will be given, you have to first calculate it and then to use it. Correct. So be sure to practice all the examples. That will give you the knowledge regarding t-test and how to and when to implement it. Thank you. Stay at home, stay healthy, and be sure to practice.